Then I'm gonna get started. So, hello everybody. Hope you're all having a very good time zone. I'm doing a talk on the Ren'Py 3D stage and camera. But first, who's speaking right now? Well, my name is Justinn. I'm hobby dev of the visual novels. I do directing and programmer roles, and I began this hobby about 2020. About 4 or 5 years ago. Here are some games I've worked on. I have a bit of a timeline here. As you can see, I am a serial jammer. But enough of that. We don't have enough time to talk about myself. We're moving on. Here is a talk overview. We're going to first talk about why scene direction is useful and why you might want it. Then we're going to talk about how you do scene direction, and we're going to do that using Ren'Py because we're talking about visual novels here, so I'll use a visual novel engine to do it. And then we're going to do some examples. Hopefully we have enough time to do all of them. Okay, so scene direction. Scene direction is the act of making cool looking scenes. So, what are scenes? What am I talking about? Well, scenes are any form of video that you can watch. You can find scenes in film and cinema, animation, anime, comics, manga, web comics, video games, and of course, can't have visual novels without scenes. And now, scene direction can be hard to think about if you don't know what tools we're using, and the tool that you use depends on the medium you're working in. So if you're doing film or video editing, you might be using Adobe After Effects or even Blender. You could do VFX in there as well. Maybe you're just using simple pen and paper, and it's all down to you as an artist. Or maybe it's a particular game engine you're using. Or in this case, what this talk's going to be focusing on is Ren'Py. It's a visual novel engine. Hopefully you've heard of it. So, yes, exactly. Ren'Py, 3D stage, and camera. This is going to be our tool to harness the power of scene direction and make really cool looking scenes. But first, before we move into 3D, we must live the 2D experience. We can't appreciate how amazing 3D is if we don't know how good we have it in the 2D space. So this is probably a scene you're used to if you've ever used Ren'Py. This is the equivalent to the default cube in Blender. This is just the default scene. You have scene BG room, show Eileen happy, right? And then you have the default script you created a vampire game. What we're probably not used to is seeing everything else around it, because we're usually stuck in our 2D space. We don't see the 3D vastness of this hidden behind the borders of the screen. Okay, and to help navigate this space safely, I'm going equipping a super shotgun for self-defense, because who knows what'll come at me while I'm talking here. This is definitely essential to the educational quality of this presentation. Okay, so first property, we're gonna blast through these. We need to look at position, or POS, short for position. If we want to manipulate the world to our bidding, then we must be able to command where our stuff needs to go. In Ren'Py, we use a coordinate system. So to help visualize our coordinate system, I'm showing a pair of axes over here in red. Put your reference to the default screen area. This is what you're used to. The origin is at the top left where the axes cross over. Positive direction is indicated by the arrows. So we have in the vertical direction, the y-axis going down here, and in the horizontal direction, we have the x-axis going along. So conceptualize our coordinate system as a grid of pixels. We have the top leftmost pixel, 0, 0, that's at the origin. The first number and the second number represent X, Y coordinates respectively. So this is currently a 1920 1080p game. This presentation, like what I'm running right now, this means that if I change X, the first number, to 1920, it's going to move that point horizontally to the other side of the screen. And notice I didn't change the second number, the Y coordinate, so it's still at the top. It just moved along horizontally. Likewise, if I just change the second number, that's the Y coordinate, to 1080, which is the height of the screen, it's going to move that point to the bottom. And if we combine both, you'll end up at the bottom right corner of the screen. And then you have every other pixel in between this grid. Perfect. So where these coordinates refer to will change depending on the size of your game. So for example, if you had an 800 by 600 pixel game, those pixels, these ones, would actually go off the screen because they're way too big. Using exact pixel values is very precise, but sometimes overkill. Instead of using a whole number pixel value, you can use the percentage of the screen width or height instead. So now notice the 1920s and the 1080s have now become 1.0s, but they're still referring to the same positions in the corners. That hasn't changed. 1.0 means 100% of the screen width or height, depending on if it's referring to the first number or the second number. So rather than knowing the exact length and width of the screen, you could use the decimal number. For example, if you wanted to go to the middle of the screen, you just say 0.5 instead of manually calculating 1920 divided by 2. Not everyone here is a human calculator. Or on the y-axis, on the second number, instead of manually calculating 1080 divided by 2. If you use decimal percentages, it'll automatically account for any screen size. So whether you make it really small or make it really big, or just right. 100% means total width or height of the screen. It doesn't matter what the actual size is, it's all relative. There is no correct answer whether you should be using the decimal percentages or the exact whole number pixel value. You can even mix and match if you want. Maybe the X coordinate is, you want to use a decimal here, Y coordinate, use a whole pixel number. You use whatever is most convenient for your design. So maybe, you have a design doc. It says move something 300 pixels to the right. Well, you could just use the exact pixel number. Or if it just generically says put this image halfway across the screen, just use 0.5. So, okay, that was one property. That was a lot of information to take in. But in practice, this is just a grid system. You just place the image where you put the point. Let's have an example. You're gonna think I'm crazy if I don't show you an example. We're moving screens. My stream should have switched to VS Code. Now I should have done this before. Now I need to go find out where the example is. Because this is the script that's running your presentation right now. Where are we? Where are we? Too late. Okay, there we go. So I'm gonna take my logo because it's nice and square, so it's very easy to see. We're gonna start off at the top left corner. So that's the origin. We're gonna set our X position and our Y position both to 0. Then we're gonna follow the same order that I presented these before. We're gonna move horizontally across. So you just set X position to 1.0. This is exactly the same thing as setting it to 1920 because I have a 1080p game. Notice how our Y position has not changed. It will still be at 0 because I set it to 0 before and I didn't change it now. Now I'm going to move back down from the origin. So I'm going to set our X position back to 0, and I'm going to move our Y position to 1.0, which is exactly the same thing as writing 1080 because my screen is 1080 pixels tall. Then I'm going to move X position back to the right side. So now it's going to be at the bottom right. And then finally, you set both values to 0.5 to put our little image in the middle of the screen. So let's double check, see that's how exactly it's working. So we're going to start at origin. Here's the little logo. It's a nice square, very easy to see. Start the origin. We're going to move across. We should be going down now. Then we're going to go to the bottom left. I mean bottom right. Don't get your left and right confused. Then we're going to go back to the center. Right. So that's exactly what we wanted, except you might be seeing a problem right now. Even though we moved the image to the center, it clearly is not in the center. So what's going on here? Well, it's because of our second property, anchor. The problem with only specifying the position of an image is that it doesn't clarify what part of the image should be placed at that point. So you can imagine this. You can use an analogy that your screen is a notice board and your anchor is this pin that you prop your image up onto. And by default, your image anchor places it at the top left corner of that image, just like how the origin starts at the top left of the screen. So with that said, this is a bit inconvenient. So if I actually wanted to center this image, I'd have to do this weird, funny math where I calculate half the width and height of this image, then offset the position to that point so that it looks like it's in the center, even though the actual position is over here in some weird off-center place. It would be much more convenient if I could just, keep it centered, but then pin the center of the image, the little nose here of the logo, over here instead of putting the top left corner. So how would you do that? Well, that's what the anchor property is. Let us change the anchor very quickly. Not live though. This is pre-written because I'm not doing a live demo. There. Here's our logo. I'm just going to set our X anchor and our Y anchor to 0.5. So that should move our pin to the center of the image. Right, so instead of offsetting our position so that it looks like our image is in the center, we're just going to center the image. And I don't even have to do any calculations for this. I just say 0.5, nice and easy. And then the pin gets to stay in the middle, which makes sense. This makes way more sense than if you put the pin in some random off-center place here. So anchor time, ta-da, boom. We move the anchor to the center of the image, and the position of the image is still in the center, which means the center of my image is in the center of the screen, which is exactly what I wanted in the first place. And now, whenever you move this, because my anchor is set to the middle of the image, when I place my image in wherever point I want, what it's placing at that point is wherever it's pinned to, which right now is in the middle because, well, that's what I decided to make it. So by combining position and anchor, you can place any part of the image anywhere on the screen. You can even recreate some of the default transforms, left, center, right. Well, that's an extra exercise for you because we don't have enough time. Okay. In summary,
say that your VS Code is showing and the
oh, I forgot to switch. Thank you for reminding me. It's okay. You did not miss anything. Because we were going to skip that anyway. So position property and anchor properties. we're moving past this. And so there's other properties as well. So you can squish and scale using your image with X zoom, or horizontally, you have Y zoom. Rotate does exactly what you think it would do. I'm not going to go through every single property here. We're going to take up the rest of this conference. But what I want you to take away from this is that position and anchor are the most important transform properties. Because for those two, you can basically make up every other one. Okay, we're gonna move again. Not VS Code. We're going to PowerPoint. I want to recontextualize what we've just done. So in this Microsoft PowerPoint, when you have images in Microsoft PowerPoint, you can move them around like this. When you put them in, when you move your image close to the center, you have this little red line. That's Microsoft PowerPoint being very clever and aligning my image to the center. You can rotate, you can scale. See, that's the level of control I want you to have. But instead of a visual interface, we're using Ren'Py, so we have to use code. This means that when you have a scene in a visual novel, you can think about, how you're gonna place your objects, how you're gonna animate them. You can make up some really silly scenes, nom 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 nom, yummy burger, and that just will enhance you. Well, you can make something a bit less silly than that. But the point is, you can think about by placing your stuff, you can help enhance your story with visuals. Moving back to the game. Okay, here's a summary we've done. We're in 2D. We talk about position, we talk about anchor. Here's everything else. You can go look at the documentation if you like. Maybe do one a day. You'll catch up one day. Okay, 3D. This is what you all came for. Before you do anything, you have to set the camera perspective to true, or else none of this is going to work. Perspective is true somewhere, hopefully. There. Camera perspective equals true. Just do that, call it a day. That activates 3D. The 3D has been on this entire time, if you haven't noticed. But for you, you need to remember to set that to true. So we have our default area. We need to expand to the third dimension, so we add another axis. That is the z-axis in this direction. With the third axis, we need the third coordinate. Ta-da! X, Y, Z. Currently, it's at 0 because, well, we just kept it there and haven't moved it. So it's going to default to 0. Exactly. When I increase that number, our image moves closer to the camera. If I decrease it, it'll move away from the camera. There is no Z anchor because, well, these are flat images. So, like, where do you put the anchor? There's only one place to put it, on this edge. Exactly. Rotation is a little bit more complicated right now. We have 3 axes of rotation. We have X rotate now. That goes along the X-axis. Y rotate goes along the Y-axis. And then finally, we have our Z rotate, which goes along the Z-axis. Combining all 3 of those, well, you can just orientate any image any way you can imagine. Okay, now we're going to move the camera. So far, we've been manipulating the world around us. Now we're going to change our viewpoint. And luckily, it's exactly the same thing, except we just apply to the camera. So here's the default scene. Everything's 0. Position 0. Blah, blah, blah. Is everything's 0. This is what you're used to. Origin's over here at the center. Where's usually? If you increase X, it'll go left. Increase Y, it'll go down. When you set the position for a camera, think about as if that's where your camera is looking at. You can use this pixel value as well. 1.0, we're going off screen now, so be careful. 0.5, we're looking at the edges. Here's the bottom edge. Here's the top edge. And of course, you have every other point you can look at wherever you want on the screen. Positive Z position, just like before, we're moving outwards from the screen. Negative Z pulse moves us into the screen. And if you go too far, sometimes you'll just end up staring into the void. And then you can apply all the other transform properties to the camera like before. So hypothetically, you are now a master of 3D. We have an example. We have room for maybe one example. Okay, two. We'll do two really quick examples. Here's a bedroom background. Now we're going to add a sprite. This is what you're used to. It's very flat right now because we haven't changed the Z position yet. What are we going to do? Yeah, so here's your text box. Everything's flat right now. I'm going to push the background back. Problem is, oh, well, first of all, why did I do that? Well, it's because we have cool parallax effect because of that. Further away things move slower than closer things. But now our background's too small. So what do? We got to scale it back up with zoom or set Z zoom to true and it'll do the zoom automatically for you. So now it's bigger. Even though it looks exactly the same and it looks like nothing's changed, it actually is still further back. It's just way bigger now. And now parallax is activated just by moving the camera around. And it may make your scene feel a little bit more three-dimensional, even if it's all just an illusion. Here's a real-world example. One final example. Let's just sneak this in at the very tail end. Here's a scene from a visual novel called Ultra Hollow that we made in Spooktober. See where there's a microwave explosion, cameras moving around anywhere, there's chaos everywhere. Let's load this scene right now. Do not crash game. Thank you very much. This is what that would look like. This is literally what it looks like in Engine. We have three layers here. We have our background at the very back. We have this purple haired girl a little bit in between this other girl and the background. Why would you want to do this? Well, it's because we can move around this scene. Maybe you start the microwave. We see who the culprit is. It was you. And then we go back over here. Someone trying to defuse the situation. See, there's a lot of things you could do with scene direction. But obviously we cannot cover everything in 20 minutes. So that was the Ren'Py 3D stage and camera talk.
Right. That was amazing. There are so many Doom jokes in chat right now, you would not believe. Okay, guys, Q&A time. So Ren Python is actually asking, is the source code for this presentation going to be available anywhere?
Not the FPS code, but there will be a similar um photo mode that will be released in February.
No. All right. Anyone else has questions? I know everyone is kind of just a little bit mind blown from having a third dimension shoved into our faces. So anyone have a question here? Yeah, some people are saying how it's like reminds them of old school Disney animation where you got layers that they put on top, which is very cool. Okay, so can you use 3D objects in Ren'Py? The Doom bit is a Pi game custom displayable, yes?
Not yet. Maybe Tom will say something later about that.
Yeah, maybe, I don't know. That would be kind of funny if it lined up that way. We'll see.
But
Okay,
no
so
3D objects right now as of this hour.
mhm. Right now, let's see. When doing parallax, is there a trick to getting distant items to move less in the background than the foreground so that it looks realistic? I know you can move them at different layers, but how do you connect it so that it all looks natural when you
What I do is I use the height of the sprite as my reference. So I know imagine you have a 6 foot tall person. You have a room that's, I don't know, 12 feet like deep. You might place your background room Z position minus um 12 feet. Well, if your sprite's like 1080, maybe you'd put it at negative 28, 2160. Trial and error basically.
Yeah, you gotta
The
play with
further the further back you place it, the slower it will move. So, you put like stuff like space really far back. There's a chair, maybe it's not that far back.
it. Okay, so someone's asking, is there any size recommendations to avoid blurriness that when you have scaling?
This is more important for the sprites and your foreground objects. So, maybe just go times 2. That should be fine.
Cool. So make them big and then you can scale it and not worry about it. Uh, Someone else, oh, Runa is saying that there's potential 3D objects uh, in their talk. So stay tuned for that. Any other questions? We got about time for one more. Is there, okay, aside from size, is there any other ways to avoid controlled blurriness that might depend, that may depend on art style?
Well, blurriness, you should just draw it like in a way that looks good in your art program. When you put it in Ren'Py, it's gonna look exactly the same, unless you move the camera close to it, and that's where you'd have to, account for that.
Apparently Python says there are some things you can do with the shader. Like, what does LOD adjust?
Level of detail.
Oh, level of detail adjust. Okay, cool.
Like maybe you don't need a 8K texture for a tree in the background.
Okay. Oh, okay. So they went to like it. Oh, they were saying that like if you have card like depending on the art style, you can do things to like control the colors and stuff to deal with the blurriness. But that depends on if you like what you're doing art wise.
Right.
Okay, we're at time. Thank you so much. Everyone's kind of hyping over this. And then the next speaker we have is, I believe it is Kigyo. Yeah. So you can get set up.
Perfect. First of
All
all,
right.
can you hear me?
Yep. Yep.
Great. Then I'm gonna share my screen. I think that worked.
Yep. You're good. It's all yours.